Hello everyone, welcome back to the IEEE SIESGST technical series. I am Siddesh Murkade, MTTS, Microwave Theory and Technology Society Head, and today we are going to kicking off a new series, Linux Essentials, getting started with Linux and the terminal. If you ever opened a terminal, seen a blinking cursor, and had no idea what to type, this video is for you. By the end of the next half hour, you are going to understand what the operating system really actually does, what Linux really is under the hood, how Linux file system organized, and you will be comfortable typing real commands to create, read, copy, and delete files all in live terminal, not just on the slides. So without wasting any time, let's get into it. Here's our roadmap for today. We are covering 6 things. First, operating system and Linux basics. Here we will learn what an operating system actually is and what is Linux really is. Second, we will meet the terminal. Here, what the prompt is actually telling you, we will discuss. Third, the Linux file system. How everything on Linux machine is organized under one single root. Fourth, navigating with commands. How to move around that file system without ever touching the mouse. We will learn here. Fifth, creating and managing files. Making, reading, copying, renaming, and deleting files from the command line. We will learn here. And at last, hands-on practice challenge at the end, so you can test what you have learned before we wrap up. Everything here builds on a previous point, so even if some of this feels basic at first, stick with me. It all comes together once we have got to the terminal. Going ahead, let's start. Let's start at the bottom of the stack. What is an operating system? Look at the diagram. At the top, you have got the user. That's you, sitting on your keyboard. Below that, there's application, your browser, your code editor, your music player, etc. Below that, there is operating system itself. And at the very bottom, you got the hardware. It's like your CPU, your RAM, your disk, your network card, and etc. The operating system's whole job is to sit in the middle of the stack between your application and your hardware. It does three big things. First, it manages memory process and devices. Here, deciding which programs get how much RAM, when it's CPU time, and how it talks to the keyboard, disk, and network card. Second, it provides a consistent interface for every application. So when your browser wants to save a file, it doesn't need to know the specific details of your particular hard drive. It just asks the OS, and the OS handles the messy hardware specific part underneath. Third, it runs continuously in the background. It's not something you open and close like an app. It's always there, from the moment you power on your machine till the moment you shut it down. Now, here's the twist. And this is important. Technically, Linux itself is just a kernel. It's only one piece of the operating system box in the diagram. So what does it actually mean? Let's look at this at the next slide. What is Linux? Really? This is one of the most misunderstood things for people new to Linux. So let's clear it up properly. Linux is a kernel, not a whole operating system. The kernel is the core program that talks directly to the hardware. It manages a CPU scheduling, your memory, your device drivers. But a bare kernel by itself isn't something you can actually sit down and use. To get a usable operating system, you need to combine four things. The Linux kernel itself, which is the set of system utilities, a small command line tool that does the basic job, a package manager, the tool that installs and updates software for you, and usually a desktop environment, which is the graphical interface with windows, icons, and menus. Put all those together, and what you get is called the Linux distribution. Things like Ubuntu, Fedora, Debian, and Kali Linux are the Linux distribution system. And here's the key idea. Every one of those distributions is running on the same Linux kernel underneath. What's different in the tool around you? The packaging system, the default types, the visual style, the philosophy. Same engine, different car basically. This is just an example. Now, let's get under the terminal. Right now, I am on Ubuntu Linux and this is the home page of it. Let's get to the terminal. This is the terminal interface of the Ubuntu Linux. We are doing most of the work on the terminal only. In further part, I'll discuss it about. So you can see here Siddesh my name at the rate Ubuntu, this colon, title, and dollar sign. This looks a bit confusing, right? We will discuss all of these. We'll actually discuss all of these in the further part. First, let's write a small command, which is uname minus r. This command uname minus r prints the exact version of the kernel I'm running. That's the Linux part we talked about. Now, now let's get further. Since we just talked about distributions, let's quickly meet the big four you'll run into the most often. First is the Ubuntu. It's beginner friendly, widely documented, and it is a huge community, which means if you get stuck, someone's almost certainly already asked your exact question online. This is what we'll be using throughout this series. Second, Debian. This is rock solid stability. In fact, Ubuntu itself is actually built on the top of the Debian. A lot of other distributions use Debian as their foundation tool. Third is Fedora. It is actually cutting edge feature sponsored by Red Hat. If you want the newest software and tools before they're mainstream, this is a common choice. And fourth is Kali Linux, which is way too popular. Its purpose it is a purpose built for security testing and ethical hacking. It comes preloaded with penetration testing tools, not something you'd use as your daily life driver, but essential if you are going into the cybersecurity. For this series, we are sticking with Ubuntu because it's the most forgiving for beginners and the most documented tool. You might be thinking, okay, this is interesting, but why does it actually matter? Let me show you how much in the world already runs on Linux. First, servers. Linux powers the vast majority of the world's servers. Every time we load a website, there is a very good chance a Linux machine is serving that page too. Second, cloud. Linux is the backbone of AWS, Azure, and Google Cloud. These are all cloud systems. When companies spin up cloud infrastructure, it overwhelmingly Linux based underneath. Third, cybersecurity. I guess there is no introduction for it. It is a standard environment for penetration testing and security tooling, which is exactly why distributions like Kali exist. Fourth, embedded systems. Your Wi-Fi router, IoT devices, smart TVs. A huge number of them are running some stripped down version of Linux. Fifth, development. It's the preferred environment for most softwares developers, especially anyone doing backend, DevOps, or systems level works. And at last, containers. Linux is literally the foundation of the Docker and Kubernetes are built on. If you have heard those buzzwords and wondered what's underneath them, it's Linux. So learning this isn't just an academic exercise. This is operating system quietly running most of the internet. Before we jump into the terminal, let's quickly talk about how you'd actually get Linux running machine onto your computer. especially if you're on Windows. First method is WSL, Windows Subsystem for Linux. This is quickest way to start. It runs alongside your existing Windows installation. No separate boot process needed. You just open it like an app. Second is, and my preferred, virtual machine. This creates a safe, fully isolated sandbox. Nothing you do inside the VM touches the actual operating system. It is perfect if you want zero risk. Third, dual boot native install. This gives you full native performance with Linux as your main primary operating system. This is most involved option and not something I'd recommend for every first step users. For this entire series, I am using Ubuntu though, and I recommend you to do the same. There is no risk on to your existing setup, and you get the exact same terminal experience you are about to walk through. All right, enough theory. Let's open the terminal. Now, anatomy of the terminal prompt. Here's the first thing you see every single time you open a Linux terminal. This prompt, user @ubuntu colon title dollar. It looks cryptic at first, but it's actually just four pieces of information packed into one line. The first part, before before the address, is the user. User means username, who you are logged in as. Okay. After that, there is address. Address is basically the host name, the name of the machine you are on. Okay. Then after the colon, you will see a title. This is the colon, and you will see a title. That's the shorthand for the home directory. We'll get into exactly what that means in a minute. And finally, the dollar. At the very end, this prompt symbol, this just sitting there waiting for you to type a command. One important tip, if you ever see a hashtag instead of dollar, that means you're logged in as a root, the administrator account with full control over the system. Be extra careful of any command you run when you see that hashtag, since root can modify or delete literally anything on the machine. Let's discuss all these things in the terminal. Look, we are on terminal right now. First, I will explain you what is the difference between hashtag and dollar. Here we will get hashtag or dollar. So for that we have to get into the administrator's account. Uh, for that we will type a simple command sudo su, and it will ask a password. I guess probably I have entered the wrong password. Just give me a minute. Right. Now we are in root administrator access. Okay. This is the administrator account with full control over the system. Okay. I'm telling again, be extra careful with any command you run here. To exit from this administrator account, you simply need to write exit, and we will be on our normal home page, home directory. Now let's clean this up with a clear command. Okay. Here's my terminal. Following exactly what we just covered, Siddesh is my username. Ubuntu is my host name. Of that title means I'm currently into my home directory, and dollar tells me I'm a normal user, not a root user. Okay. I guess you have understand what is the meaning between dollar and hashtag. Now let's write a simple command. Who am I? Whoever just prints out the current logged in user, confirms that the first part of the prompt. Now, hostname. Let's write the next command as hostname, and hostname prints the machine's name, confirms the second part. Nothing mysterious about that prompt anymore. It's literally telling you who you are and where you are at all times. Basically, prompt means that commands. Okay, don't get confused in it. Prompt means commands. Okay, these commands. The first prompt is who am I? The second prompt is hostname. Okay, now let's get to the slides again. Okay, quick but important detour before we go in deeper into the terminal. Why? Because why use the command line at all when you've already got a perfectly good graphical interface? First, GUI interface. It's visual, point and click intuitive for everyday tasks, and honestly, a great starting point for beginners. Nobody's saying nobody's saying GUI is a are bad actually. It's not. CLI. CLI means command line interface, which is what we are which is why actually we are focused on today. Its strengths are different. It's built for automation and scripting. You can save a sequence of commands and run them again anytime. It's faster for repetitive tasks, like instead of clicking through 10 folders, to type one line, and it's all it needs. It's essential for remote servers also, where there often isn't a graphical interface at all, just a terminal connection. And it gives a full control over the system in a way clicking menus never fully can. Okay, so the honest takeaway here, it's not that one is better and another is not better. The terminal simply unlocks things a GUI can't, especially once you can't automating things or working on remote machines. That's exactly why we are spending this whole series in the terminal. Now, let's get into the Linux file system hierarchy. Let's talk about how Linux actually organizes your files, because this trips up almost every beginner coming from Windows. Everything in Linux starts from a single root, written as just a forward slash. This forward slash. There's no C drive, no D drive. One single tree, and every single file and folder on your entire file system lives somewhere under that one roof. Look at this tree. Right under the slash, you've got several important folders like home slash home. This is your personal files for each user live, your documents, your downloads, desktops, all under here. Second is root. Don't confuse with the slash. It's specifically the home directory of the root user, the administrator's account. Third is except etc. It holds the system configuration files basically. Almost every service on your machine has its settings stored somewhere in here. Fourth is var. This is for logs and variable data, things that changes and grows over time, like system logs. TMP, temporary files, and this one gets cleared out often. So never store anything important here. Like temporary files are not a place where you should store a permanent folder or permanent data. Temporary files always cleared out or always gets deleted and always gets formed again and again. Next is user. This is where most of your installed programs and utilities are live. The last is dev, dev, device files. which is actually a Linux clever way to represent your actual hardware, your disks, your USB devices as files you can interact with. Let's stop looking at the diagram and go at the real thing, which is terminal. Okay, now let's type one more single command. First, clear this up. Okay, now I will type a small command ls space slash. There it is. All that's actual root of my file system, and you can see almost every folder we just talked about: home, root, etc. Where 10, user dev. This isn't a diagram anymore. This is actually genuinely how my machine is laid out right now, and it will look basically identical on yours. Let's peek inside the couple of trees. Okay, so we'll type for getting into the trees. We'll type cd etc. CD command is basically you if you want to move deeper into the file systems, you need to write the cd command and etc. Now we have got into the etc etc folder. Okay, sorry, I'm saying again and again, I'm saying etc etc, but it's actually etc folder. This etc a file configuration file, exactly like we said. You can see things like host name and host, which controls machine learning and networking. Let's see. See here, all the directory is stored up here. Okay, then let's go into where one. Let's go under where. Okay, now look, we are under var directory. If you want to see what's inside the var directory, we just simply use ls, and here we got backups, cache, crash, leave, local, etc. Notice that log folder sitting right there. That's where system logs actually got written. Okay, now let's get back to somewhere safe, our home directory. Okay, for getting back to the home directory, we simply just need to write cd and title. There we go. We have got into the home directory. Good, we are back in this familiar territory basically. Now let's talk about how I just move between all these folders, because that's our topic. That's our next topic, paths. Okay. If you are coming from Windows, you're actually used to paths that looks like C users, like something C users, C documents, and all something like have just taken a example with a drive letter and backslashes. Linux does this completely differently. The equivalent path in Linux would be home slash user slash documents. Everything starts from slash, and there are no drive letters at all. See, you can see here in Windows, you can see C drive, D drive, but there is no drive letter in Linux. Now, there are actually two ways to describe where a file lives, and this distinction matters a lot once you start writing scripts. First is absolute path. An absolute path is like basically a full path starting all the way from the root. For example, home, user, documents, etc. No matter what folder you are currently sitting in, this path always points to this exactly the same place. But comparatively, relative path on the other hand is measured from wherever you currently are. For example, if I'm already sitting inside slash home, like for example, slash home slash user, then just type documents slash projects, get me to the same folder, but only get me to the same folder basically, but only because of where I started from. Run that exact same relative path from a different folder, and I'll take to the somewhere else completely different, or the command will fail entirely. Let's actually feel this the difference between these two. Now I'm actually under home, my home directory. Okay, I'm currently in my home directory. All right. Now for checking this, we will write pwd. Yes, we are in our home directory right now. I'm current. Let's make the small folder structure to play with. Okay. To make a small folder structure, we will write a simple command mkdir minus p. Now we have to write under what we have to make this folder. So we will give a path document slash projects. Okay. Okay. Now if I want to get into the project folder, I have two options. Option one, the absolute path, starting root. Okay. For that, I have to write cd slash home slash cds slash document slash projects. Okay. Now, if we do right, if you check where we are inside the project folder. Okay. That works from anywhere on the system. I could type the exact command from inside the etc directory folder, and I would still land. It will still land me here. Let's go back and try the second option, which is using relative path measured from where I am right now. Okay, so for example, I am in home directory. Okay, pwd. I am in home directory. Now I just have to write cd doc, document slash projects. Okay, okay. I guess I have written the spelling wrong. Let me correct it. Okay, see, same destination, but this, but one thing we have to think that this only be, only work because I already inside the home folder when I typed it. If I had been sitting in etc directory of folder and typed the same relative path, it would have failed because there is no document folder inside the etc. That's the core difference between absolute path always work or from anywhere. Relative path depends entirely on where you are currently standing, but the absolute path works from anywhere you are there. You give any path to it, it will properly land you there. Now, let's go to the navigation commands. Let me formally introduce to the core set of the commands you use to move around the Linux every single day. There are really just a handful of them. First is pwd, print working directory. It is print working directory, tells us exactly where you are currently. ls lists the file. It actually lists the files and directories in your current location, like we have seen before. When I was typing ls command, each and every files and direct directories in my current location was displayed. ls minus l display details. Okay, ls minus l, the same listing but with detail, permissions, size, and data. Okay, ls minus a, it lists everything, including hidden files, anything starting from a with a dot. Okay, next is cd directory, cd command. This is used to change into a directory. Okay, if you want to go from here to there, this cd command is used. Cd double dot. This command moves you up one directory level to the parent folder. Next is cd title, jumps you to the home directory. We seen this earlier. And cd slash, it's this command jumps straight you to the file system. I already used a few of these a moment ago, but let's now go to the very single one of this properly, back to back with the terminal. Okay, let's go back to the home directory. Okay, now we are in the home directory. Let's clear up this mess. Okay, now we will write first command ls. It lists all the what's inside the current folder. Right now, just the document folder we made ago. Okay, the document folder. Next is ls minus l. It gives me the long listing. You can see the permissions on the left, the owner, the size, and the data it was last modified. We'll go much deeper into permissions afterwards. Next is ls minus a. It shows all the hidden files too, anything starting with the dot, like bash arc is normally hidden from the plain ls, but system and config files are very often stored this way. Notice dot and double dot as well. Dot means a current folder and double dot means a parent folder. Okay, now the next command is cd command. Let's see that I want to go into my documents folder, and here we are. I'm currently into my document folder. See, then we will use cd dot dot command. Look, it take me back up. It take me back to the home folder, parent folder. That's this one's essential. We use it consistently. Okay. Now cd title. Okay. Okay. First we have to go inside any directory. Okay, like documents slash projects. Okay. Now we are in projects folder. Okay. Now I will use cd title. Look, and I can always jump straight from the very top of the file system with cd title. Okay. Back this that's completely localized for moving around Linux. pwd ls minus one, ls minus a, cd dot dot, cd title. Ah, we have forgotten one actually. Okay, so if I write cd slash, then I am under slash. Okay, and if I want to get out of it, cd title will get me off that it. Now that's a complete Toklai toolkit for moving around the Linux, each and every command. Everything else we do from here on out builds directly on top of these 8 commands. Okay, now let's move forward. File systems and directories. Now that we can move around, let's actually create and manage things. This slide shows one continuous realistic workflow, 6 steps from creating one folder all the way to cleaning it up. Let's read through the commands first and then go exact same things like step 1, create and enter. Here we will use mkdir command which creates a new folder and cd which is used to move it. Okay, ignore the Linux demo. We will write the actual paths here and sorry, we will write the actual paths here and actual folder name here. Step 2 is creating file. Here we will use touch command which creates a brand new empty file. Okay, step 3, uh, echo command. Write to it. For writing, we will use echo command which writes text directly into that file. Next is read it. In next step, we will read what we have write in that file. Okay. Next step, copy and renum, and then clean up. Let's actually run every single one of these live right now. First, let's clear it up. Okay. First, let's create a file. Okay. A file like mkdir Linux demo name. Okay. A file is now created. Let's go under this file. Actually, folder where I should say cd Linux demo. See, we are under Linux demo folder, or we can say directory, Linux demo directory, my bad. Now, let's do the step 2, create a file. For creating file, we will use touch command and create a file named notes.txt. A note.txt file is now created. Let's check what is there in Linux demo directory. See, notes.txt file is now created. The touch command basically creates a new empty file. If you run ls, you will see notes.txt now sitting right there, 0 bytes, nothing written inside it. Now let's do the step 3. Write something into the into that file. For that, we will use echo command like echo. Now let's echo command will write anything which you tell, which you type, and which you want to save inside the notes directory. If I want to write something like Linux essentials, and one thing to notice, I will give a angular bracket notes.txt, then something is written into the notes.txt. Linux essentials is written into the notes.txt. Echo normally just prints text to the screen, but that angular bracket, this the angular bracket symbol redirects that output. Instead of printing on the screen, it gets written straight into the note.txt, where we are going to dig much deeper into the angular symbols in the next slide. So hold that for now. Okay. Now from this command, the Linux essential, this word, this text is get edited into the notes.txt. For cross verifying it, Let's read it. For reading, we will use cat notes.txt. Okay. See, cat command actually short for concatenate. It's a short form of concatenate, but in practice, just think it as print this file content command. Okay, and there it is. The next text we just wrote is genuinely sitting inside that file. Okay, next is copy and rename command. Now, for copying it, we can use that notes.txt, sorry, txt to backup.txt. Okay, now this command tells that I am copying the notes.txt's content into into the backup.txt file. Okay, let's check one more time. Ls see. Now backup.txt and note.txt is formed. CP makes the full copy. Okay, basically it makes a full replica copy of the content inside the node.txt and also make a new file where all the contents of node.txt is being copied. Now I've got two identical files, node.txt and backup.txt. Okay, next command is move command. So I will move backup.txt to final notes.txt. Okay, run this command. See, now all the contents inside let's make this thing simple. Move is Linux command for both moving and renaming the file. There is no separate rename command in Linux. You just move a file to a new name in the same location. Notice backup.txt is gone now. See, backup.txt is gone and final notes.txt has taken its place. Okay, now the last step, cleanup process. Cleanup. Oh, sorry. For cleanup process, we will write rm command. Okay, rm final no rm final notes.txt. Okay, now let's check by ls command. See, rm deletes it. One important warning here. Okay, rm does not send file to a recycle bin. Okay, this is the point you should note. The rm command, means remove command, does not send a file to the recycle bin. There is no recycle bin. Once you run it, the file is gone, completely permanently gone. Always double check the file name before you hit enter on rename. And that's a complete life cycle of the Linux files in the Linux. Okay, create, write, read, copy, rename, delete. These six commands, and you can now manage files entirely without ever touching a mouse. Okay, let's go to the next slide, which is redirection. Single angle comma angular bracket and double angular bracket. What is this? That symbol, single angular bracket, we used a minute ago because it's genuinely one of the most useful things you will learn today. There are two versions of this: single angular bracket, which overrides, and double angular bracket, which appends. Okay, watch this sequence. Echo hello file.txt. Okay, then cat file.txt that prints hello. Okay, now if I run echo hello file.txt again, followed by echo world echo world, double angular bracket, file.txt, and then if I want to see what is inside that file.txt by using cat file.txt, this time you will get hello world. This rule is simple. Angular bracket creates this file if it doesn't exist, or completely wipes it and starts fresh if it does. Double angular bracket adds a new content to the end without touching what's already there. Mixing this up is genuinely common mistake. Using angular bracket and using angular bracket when you make double angular will silently erase everything that was in a file before. Okay. Now let's go further. Now it's time for the practice challenge. Alright, we have now seen every command you need. Time to actually test yourself, because watching someone easily type is very different from typing actually yourself. Here's a challenge in 5 stages. First, create a directory named Linux Practice. Create 2 files inside it. Third, add some text to one of these files. Fourth, copy that file and rename the copy. Fifth, inspect the directory with ls to confirm everything there. Okay, using only what we have covered today, mkdir cd touch echo with angular bracket cat cp mv command and ls command, you have to put together this, you have to complete this challenge. Okay, the goal is just to get your fingers moving those commands without me guiding every keystroke. Okay, time's over. I guess we have completed the practice challenge. Let's move ahead. Now, time to quickly recap everything we have packed into this session. We have explained the Linux distributions, distributions. We have demystified the terminal, the cryptic prompt, and everything. We mapped the file hierarchy mapping. We have covered the absolute versus relative paths concept. We went to the core navigation commands, like we have learned pwd, ls, cd command. Okay, and we covered the file and directory operations. Okay, creating and reading, copying, renaming, and deleting, plus difference between the angular single angular bracket and double angular bracket. That's genuinely a complete practical foundation. If you can comfortably do everything just did, you are no longer intimidated by a Linux terminal. And that's a real useful skill. Now let's wrap up the Linux essential part. Thank you so much for watching this one, all of you, all the way. If you followed along in your own terminal, you're already ahead of where most people are after their first Linux tutorial. Drop any question in the comments if you have any doubts and something. Thank you so much.